The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
So Pervious Concrete and the student competition, as John kind of mentioned, we've been doing it since 2010. We've done it 3 times now. We've got another one coming up soon, in another year from now, in Denver. So my subtitle is, this has come from one of the competitions, is it really pervious if you just use normal concrete and drill holes through it? So that's a good question. What I'm going to cover, just a general overview of the student competitions, how they work, this competition in specific, and then some of the more interesting stuff, what we're seeing the students actually submit and how that's changing over time, and then what we're trying to do moving forward. So the student competition, if you come in early enough, on every Sunday, it runs most of the day, usually in the exhibit area. Idea is to try to expose students to concrete, get them to the convention, compete against each other. They get pretty riled up. There's a bowling ball competition there and a new mortar workability competition where they're actually making mortar on site. We did that here. But I definitely recommend checking it out on Sunday. That they get pretty eager, to say the least. So this is a shot from this convention. It makes it more impressive because we were packed into a tiny sardine can with approximately 300 students and their advisors. For example, we had 23 teams for the egg protection device this time, another 16 for the mortar workability. Pervious, we're usually getting around 32 to 35 teams of 4 to 5 students apiece. So it's been real popular. Hopefully that keeps up. The way the competitions work, we have 4 to 5 that we rotate every so often. So here we've got FRP is coming up in the spring, and then we've got Pervious, and then we've got the bowling ball. So we kind of are on this rotation so that the students are doing new things, but then it's not reinventing the wheel. You know, it essentially happens every 2 years. So hopefully there's some knowledge transfer and improvement over time. Some of the teams it gets completely crazy. In 2013, for one of the teams did, I think it was 42 mixed trials. So again, they take it pretty seriously. There is some pretty good money involved. There's usually 2 different categories to win. First place, they get $750, so you could take home $1,500. If you've got 2 teams from your university, you could bring a lot of money back for your student chapter. Here's one of the flow charts showing their 5 mixed designs down there in the corner. Some overview, general Pervious, some pretty stuff that Scott putting in on the West Coast, some local stuff near me in Chicago, in some backyards. So that's you know, the Pervious that's going down in the street that people like to look at. That's what it looks like, which is, as you'll see, a little bit different than we're usually getting for the competitions. Where this all came from, as John kind of mentioned, we had the cylinder competition going for a long time, and it was getting pretty stale. Everybody's just trying to make high-strength concrete, and you know, there's really not a lot new happening. You can only change the rules so many times to try to make it exciting. There's a big sustainability push from nationals. So Kansas City chapter is really good with their students and hosts local competitions. So Larry, who is in charge of the student competitions at the time, worked with John to kind of come up with this idea for a competition. They hosted it locally. There's our first iteration on our infiltration device there. And then it worked well in the local level, so we scaled it up and did it in Chicago for the first time in 2010. With Pervious, there's this trade-off, which I think plays well with the students, is that so you want to make it strong, so we test the splitting tensile strength. But to make it strong, you have to make it dense, and by doing that, you're sacrificing infiltration. So then we're testing infiltration as well. So they kind of have to balance these things, and that's how we assigned the other 10% was for their report, which is kind of trying to encompass the kind of mixed design aspects of the cylinder competition that this would be replacing. 32 teams the first go at it. The winners were a good balance. The top teams were more in the 6th place for infiltration and 8th place for strength. So they did work on that balance. There were teams that, which I'll kind of get to, that kind of would sacrifice one for the other on purpose. And again, after this, ACI National was really pushing sustainability, so they asked us, rather than waiting 2 years, could you do it a little faster? So we had a little bit quicker turnaround, and then did it again in 2011, the second time in Cincinnati. And there we kept things similar on the overall category, so the same weight for infiltration and strength. But then we added a second category, load to cost. So that kind of more wrapped a little bit more true sustainability. We gave them credits for some of their, fly ash replacement or using an actual available aggregate instead of a crazy custom blend. As you can see, I've got it down at the bottom. That's the cost sheet. So a standard aggregate, we put it at $15 for a ton versus your custom aggregate at $45, for example. So we also changed the testing device to put a little bit of back pressure, because otherwise the water would just fall through and kind of create a bit of an airlock, and it was just from a mechanics standpoint. Yeah, John made this change, and it definitely works a lot better. It's a lot more repeatable too. But again, we had 32 teams come to compete, and they were having a good time. What we did see, though, is a couple of the teams figured out the load to cost only really includes load, right? So they made their specimens, University of Minnesota Duluth comes to mind. It sat there in the infiltrometer, it just sat there. And well, there was no limit on infiltration. I remember arguing with the students, you had to make pervious. Well, for the rules, yeah, it's technically pervious because there were a few drips that came through. It's like, okay, fine, lesson learned. They did win the load to cost category, hands down. Yeah. So here, for the third iteration, we tried to prevent that a little bit, put a little bit more weight on the actual mix design itself, which I'll show partly because the students are actually having trouble with mix designs. I think that's somewhere that the students aren't very strong in. But then I also, for the load to cost, I made it a 200 inches per hour minimum in order to compete in that category, which is a great number when you're doing 1701 on the ground. In the field, that's a good baseline number for infiltration. I didn't really think about it, and when you're putting 8 inches of head in an infiltrometer, that's actually not very low, or that's actually like really low. So it didn't really work out. We still had some teams that pretty much sacked the infiltration and went for the high load. But I guess next time we'll try to catch that. 35 teams came to Phoenix. Unfortunately, the Great Excel infiltration equation debacle occurred. So that's all I can really remember from that competition. In the going between competitions, one of the equations in the spreadsheet was different for about a third of the teams, and I didn't catch it. It's just kind of like some carryover. Announced the prizes, everybody's screaming yay, yay, and calling the president of the university, we got this, and then one of the teams is like, man, we just thought we'd do much better. And there was another team that was, boy, we thought we'd do much worse. And so I start looking at it right after the lunch on Monday. Oh, no. It was bad enough. It changed all three top teams completely. And it was a mess. There were meetings with ACI president, and yeah. So we'll try to avoid that in the future. But on to the actual student submissions and how they've evolved. So first, and this is where the subtitle of the presentation comes in, one of these things is not like the other. You see that third specimen there? That's University of Illinois at Urbana-Champaign. The team members is right here. They made normal concrete, but they cast in three, it's about an 1/8 of an inch diameter rods that they then pulled out of their specimen, and that was their Pervious. So again, they tried to argue. We ended up throwing them out because there was a line in the rules that said it's supposed to be a homogeneous mixture, so we got them on that. But we did end up testing it, and they wouldn't have won. They just needed more holes. If you just put more holes in it, you probably would have done pretty well. But there were only 3. But generally, the mixes were really just raw and ragged. They still are often, but a lot of just 3/4 inch stone, paste holding it together. I'd hate to walk over it in high heels. You know, it would be a mess. I often walk in high heels, yes. So here's one of the interesting teams. Well, so see, there's the data there. It is pretty impressive. Almost 300 psi average splitting tensile. Keep in mind, quite a few of the teams, while there are some doing 40 trials, quite a few of them are, oh no, ACI convention is next week, we should make some concrete. So you kind of have to take that all into account. Those drainage rates, so later when I made it 200 inches per hour minimum, you know, those are the numbers we're dealing with, so that wasn't near good enough. The infiltration rates are just astronomical, partly because they've got that big stone. But this is a overview of this team's, I think it was UMKC, no, Missouri S&T, of their mix. They've got a quaternary mix. They've got slag, they've got silica fume, they've got fly ash, they've got cement. They had like 3 different aggregates. That's what all went into their mix. It's pretty good stuff. So yeah, there it is. I thought that was pretty impressive. 12 pounds a yard of fiber. Fiber guys would love it. Then the student teams in general love silica fume. They all put, I think Tony's just handing out silica fume to the schools like crazy. And 2011, second try at the competition. The mixes are somewhat a little more realistic. Like I just said, boy, those students love silica fume. 5 and 10% in a mix is just normal. There's been a few where it's closer to 20. Nice dark mixes. Often, though, what I kind of commented on earlier, for the actual mix design, a lot of them forget about the voids. So they add everything up. They've got their 27 cubic feet in a cubic yard, but they forget about the fact that they designed for 20% voids, and you know the mix doesn't yield right. And so I think that's something we as a committee have to give them a little bit more guidance on, that I don't think they're getting in school necessarily, because quite a few teams that's true. So like for this one, you know, this team has their 27 and, you know, no voids. That's a picture of the UM Duluth team that made that real dense mix. Small aggregate, real tight, lots of paste. It didn't drain, but they got, you know, almost 700 psi splitting tensile, which is pretty impressive. This other sample over on the side is the one that got the 14,500 inches per hour, which is just really hard to wrap my mind around. I think that's the depth of Lake Michigan. It's got to be something like that in an hour, you know. But again, the teams that did real well were really well balanced. This team had 420 splitting tensile, 5,100 inches per hour, really nice mix, a little bit of fiber in there, silica fume. Move on to Phoenix. Again, you know, the evidence that having trouble with the mixed designs, just not doing it right. Some more, you've got super fiber. I think that's 16 pounds per cubic yard. This mix actually did really well. I think it was second place, 600 PSI split, and a pound of fiber in it. Honestly, it doesn't look too bad as a mix. Ryerson, that actually looks like good Pervious. They won. They had 475 split and a little over 2,000 inches an hour. And kind of where are we trying to go from here? We've done some talking on trying to get the students a little bit more exposure to real-world items like a specification. Not completely sure how we tie that into the problem statement for the competition, but especially trying to limit those unrealistic mixes, the huge aggregate, the tons of silica fume that they'd never be able to place. But we're starting to work on that. Or maybe it'll lead to a new raffling test. It's a 20-hour slab with a truck burning out on it. But thanks for your attention, and I hope to see you at the convention in Denver for the Pervious competition.